Let us solve this problem which was given for practice. So you are supposed to find out the maximum force that can be transferred through the double covered butt joint which is shown in the diagram. So we have two plates which are 16 mm thick and they are covered on either sides by 10 mm plates, and it's a double butt joint. See the arrangement of the bolts which are given in the diagram. So we have three sections: section 1 1, section 2 2, and section 3 3. The pitch and the gauge distance are also mentioned. So let us start solving this problem. We have been given that M20 bolts have been given of grade 4.6. The diameter is 20 mm. So the diameter of the hole would be 20 plus 2, which is 22 mm. FUB for 4.6 grade would be 400 Newton per mm square. And for the steel plates of 410, the ultimate strength would be 410 Newton per mm square. Now let us calculate the nominal strength of one bolt. Nominal strength of one bolt in shear. Now since this is a double butt joint, there will be two shear planes, therefore this is double shear. We know that in case it is a double shear, then we take NN as 1 and NS as 1. Please go through the notes that were shared earlier. And the nominal shear is given by FUB upon root of 3 pi by 4 into t square. So substituting the formula for FUB and D. Here we are talking about the bolts, that is why the value of FUB is 400 Newton per mm square. This 1.78 is because 1 plus 0.78, because we are talking about the same diameters. I remove this term common out. Into pi by 4. The nominal diameter is 20. And this works out to be 129143 newtons. This was the nominal strength. Now we need to find out the design strength of one bolt, which is given by the nominal strength divided by the partial safety factor, which is 1.25, and the value of this is 103314 Newton. Now this was of a single bolt. If we want to find out design strength of joint in double shear, we have to multiply the number of bolts. So the number of bolts is 6 multiplied by 103314 will give us 619,886 newtons, which is 619.886 kilonewton. So this is shear. Next we need to find out the strength of bolts strength of bolts in bearing so we need to find out KB, which is the least of E by 3d0 P by 3d0 minus 0.25 or FUB upon FU or 1. Now we have three critical sections here, so we have to calculate for the worst condition. So let us start with section 3.3. The end distance is 40. The pitch is 60. So at section 3.3, the minimum one is 0.6061. The same procedure we repeat for section 2.2 and section 1.1. Since the value of E is large, KB1 and KB2 work out to be 0.6591, which is governed by 3d0 minus 0.25. The nominal strength of 6 bolts in bearing is plus 3 into 2.5 into 20 into 16 into 410, the value of which is 1244957 Newton. This 3 here in this formula refers to section 3.3. So there are 3 bolts in section 3.3 and this KB value is corresponding to the section 3.3, whereas this 3 refers to the total of section 2.2 and section 1.1. So this KB value refers to KB1 and KB2, which are equal in this case. Okay, so the number of bolts was 6, so it is this 3 plus this 3 here. Okay, so it is 6. So this is the nominal strength. We need to find out the design strength in bearing. Design strength in bearing, which is 1244957, that is the nominal strength upon the partial safety factor of 1.25. 995,965 Newton or 995.965 kilonewton. So this is greater than the design strength in shear. So if we want to find out the strength of the bolt, it is a minimum of the 2. So the strength of the bolt is 103314 Newton as calculated in shear, and the strength of bolts in the joint is minimum of 2, which is 619.886 kilonewton. Up till now we have calculated the strength of each bolt and the strength of bolts in the joint. Next we need to check the strength along all the 3 sections. This we will continue in the next video. Thank you.